Hi guys, welcome to Learn Electronics Repair. Let's have a talk about potentiometers. So this video came about really from some comments that somebody left when I made the guitar repair, which had a faulty potentiometer. And a few interesting things were raised, and I got the impression that some people are a little bit confused or don't know exactly about these components. So let's make a short-ish video about potentiometers, okay? So basically a potentiometer is a variable resistor. That's what it actually is. So it has a carbon track inside and a wiper that moves across the track and therefore allows you to set the resistance. That's what it actually is. I'll just draw on a bit of paper what we have, and then we can look at some of these. The symbol for a potentiometer is this. Okay. That's a potentiometer. It has 3 pins on the device. As we can see, this one has 6. We'll talk about that in a minute. You'll sometimes also see the symbol like this. Okay. And occasionally you'll see like this with either of these 2 symbol variations. Yeah, so you'll sometimes also see them like this. Okay, or that one with the diagonal arrow through. And there's a variation of potentiometer called a trimmer pot or a preset pot or preset potentiometer. So this is the type that you set once, usually with a screwdriver, and then you leave it. So unless you need to recalibrate the circuit, you don't adjust it. And the symbol for that one, again with either of these 2, is like so, okay? So that's a preset or trimmer pot, and these are potentiometers. You'll see the device has 3 legs, and they tend to be wired in 3 different ways. So sometimes you will find them wired like this, where one end doesn't go to anywhere, it's not connected to anywhere, the other end is connected into your circuit, and then that is your wiper or slider, okay? You find them like that. Sometimes you will find them whereby you have both ends connected, possibly one end to ground and one end to some sort of supply voltage, and the wiper like so. And sometimes you find them connected this way, so not necessarily, but could be to ground, and then your wiper is also connected to one end, either end. Okay, so you'll sometimes find them wired that way. So that's how they're generally used in circuits. This effectively is just a variable resistance. Okay, whereas this one acts as a voltage divider. So if you imagine you had like 5 volts on here and 0 volts on here, with the slider at this end, the output would be 0. With it at that end, it would be 5. And with it somewhere in between, the voltage will be somewhere in between. So that's how they tend to be used in circuits. The reason we connect potentiometers like this, by the way, is to stop the resistance going to infinite if the wiper loses contact with the track, which may blow something up further down in the circuit. And it also helps to reduce crackling and noise in audio circuits as well, because you'll always have a contact directly across the track, one end to the other, even if this one is effectively losing contact as it moves across. So that's why that's done. When we connect the potentiometer with the wiper fixed to one end, like so, we effectively have 2 terminals now because the wiper is attached to this point. So we can only use this as a variable resistor. It's not a voltage divider. The resistance from the wiper to this end will always be 0, and you can connect it the other way. If this was some sort of positive voltage, you can connect it the other way. Okay. An interesting thing with this, and I'll just show you this, although it is obvious, but once I've shown it, it'll be very obvious. So here is a potentiometer. Here is the multimeter. And if we measure from the wiper to one end, it's reading a low resistance. Okay, and the other end is reading a high resistance. And across the track is reading the high resistance, which on this is 10k. And it doesn't matter where you put the wiper. Okay, this will always read 10k. But the wiper, the resistance will change depending on where we put it. Okay. Now look what happens when we attach a connection between one end and the wiper. Okay. We'll turn the potentiometer over this way. And we know because these two are attached together, obviously we have 0 ohms here. And across the track we'll have 10k. But look what happens now when we adjust it, yeah? I'll adjust it. And the resistance across the entire track changes. Yeah. Okay. So it's now varying the resistance across the entire track. So that's just something just to keep in mind when you have a potentiometer wired like this, that the resistance from one end to the other will change as you move the wiper. Here are some preset or trimmer pots or preset potentiometers. You'll see they come in a variety of different types if you like. Some, like these, are multi-turn ones. These are horizontally mounted, some are vertically mounted, but they're all basically the same thing. They will normally be marked, if they're marked at all, with the value of the resistance. So this one says W500. That is not a 500 ohm potentiometer. It's 50 and no more zeros. So that is a 50 ohm. Yeah, and I think all these in this little batch were all 50 ohms. But if you're not sure, you can find out by just measuring across either end of the track. So we go on to ohms range, and if we just measure across from one end to the other, yeah, 60 ohms. Okay, it's within tolerance. From one end to the wiper, well, it'll depend on where the wiper is set. That's reading 40, and that's reading 39. So that's how you actually measure them, okay? Just to show you the way these are marked, I just mentioned. So this one is actually marked 501. Just get a better light on it. And that is a 500 ohm, okay? But they're not always marked like that. You may find a different brand actually says 500 is 500 ohms. So unless you measure them or you are familiar with the markings on that particular component, you may get confused. There's also another thing we need to know about our potentiometers, and that is that basically they come in two varieties, which is logarithmic and linear. I think there's actually another one like an anti-log, but never mind, yeah, because I'm not so sure about that one. So the way you can normally tell is by the marking on the components. These that say B100K are linear ones. So any that say B are linear, okay? And what that means is that the resistance will vary evenly across the track. So with this one, if we measure directly across the track, this is a 50k, and it reads 50k, close enough, and it will read 50k across the track regardless of where you put the slider, okay? Now if we put the slider to this end, this should read 0 or close, okay? And this end should read 50 or close, yeah? We put it to the other end, and this will now read 0, and this will read 50. And with a linear potentiometer, if we set it to halfway, I'll just try and figure out where the halfway is. It's about there. So if we set it to halfway, we should read half the resistance. This is a 50k, so it should read about 25. Okay, close. Close. Obviously, depending on where I position, it will read slightly different. Yeah. But in the middle position, if it reads half the value, that is a linear one. We also have ones like this. So this is another linear one. And this isn't marked either A or B. This is a 470k. And if we look at the markings on this one, here, it says lin. Okay, so that's another linear one. Again, we can just find roughly the halfway position, which is about there somewhere. And from the wiper to either end should read half the value. Yeah. This is actually, yeah, 254, roughly half of 470, 500. Okay. The other type we find are logarithmic. This is a slider potentiometer, and this is marked A10K. So A is a logarithmic, 10K is a value. Okay. And you'll find with these ones that we have two terminals marked 2, and they're both actually connected together. And that is the wiper, I think. So one is reading almost short, and that is reading 10k. Okay, move it halfway down. One has now changed, and this is reading 10k. Okay, now if you look at this one, this is logarithmic. So what that means is that if we go to one end, almost 0, a little bit, 44 ohms, bit more, 330, so it went up a lot more. Again, a little bit, went up a lot more. Okay, so with this one, towards this end, the adjustment changes rapidly when we move that, and towards this end, almost no difference. So that is a logarithmic one. These are normally used in audio circuits. There's good explanations if you want to look at the mathematics of why, but these are used in audio circuits mainly, and you need to fit the right type, and not just physically the right type and the right value of resistance, but the correct type. Otherwise you'll find your potentiometer doesn't adjust the signal correctly. So what's inside a potentiometer? Well, let's have a look at one. So this one is a 100k linear. Yeah. Let's take it apart and let's have a look to see what's inside it. Easiest way to do this, in fact the only way, is to bend these little tabs up and then it should come apart. They're not difficult to get into, and if you're nice and careful, you can do it without damaging it, and it will easily go back together. So just prise that up a little bit. Okay, just push it back. Same the other side. Okay, last one. There. And it should now come apart. So we'll take the top off. Okay, or we'll take the back off rather. There you have it. And this is your potentiometer. So effectively you have like a wiper you can see moving along the track there, and a track here. Once I've taken the top off, it'll spin all the way around, because that's what that little stop was doing in there. It was stopping it going past the end of the tracks. Okay, we can dismantle this further. So we can take this little plastic piece off usually. Okay, it flirted off, but we now have it apart. So this piece is the actual wiper that's moving across the track, and this is the carbon track. If we have a look at this, we'll use the meter again on resistance mode. We can see, if we go from one of these tabs here, you'll see the carbon track, the first part of it is metallized, okay? And then we have the carbon. So from here to here, it should basically be 0 ohms. And then we start on the track. Okay, you can see a little bit of resistance there. As I move around it, you can see the resistance increasing until we come to the other end, and we have about 10k. Yeah, let's just go back a little bit. So this end is just moving by a few k. I've lost connection on it for the moment. Okay, whereas if we get towards the middle, about the same actually. This end, about the same sort of adjustment. So that one is a linear one. No matter where I go on the track, I get roughly the same amount of adjustment. So if you have one of these that's broken, that's how you can determine A, is it linear or logarithmic, and B, what is the value of it. Okay. What tends to go wrong with these is usually one of three things. Quite often the connection from here to here will break. Okay, so you can end up with an open circuit from there to there. You can normally get a bit of solder on, but sometimes it's difficult to do that. And what I recommend you do, I'll just give this a little shake, is use this. So this is conducting silver. Okay, this is paint. So if you just add a little bit of silver paint here, just get a drop onto here, onto this end, leave it till the next day, it will be fine. Yeah, and you can do the same thing exactly with these slider ones. I'll just show you one. So again, we use the same method. We just bend the little metal tabs. Okay. And then we can take the back off this. Okay, and here again you can see, so this actually has two sliders. One goes along this track, which is just conductive between the two terminal 2, so you can use either one end or the other basically to connect to, or you can connect to both ends, and then the other one goes across the track. So again, we can look with the meter on this one. So from here to here, almost 0 ohms. This is just a track. Okay, and then we have from this one to one end of the carbon track here. This is a carbon track. You can see the resistance changing to the other end. Okay, so 10k. If we come to the middle, it's not half, it's nowhere near half, so we know this is a logarithmic one. Once again, you'll often find you get a break here or a break here, and a little bit of the silver conductive paint will do the job. If you try to solder it, you probably can't, and you'll probably just end up breaking it. Okay. Another thing that goes wrong with these is they become noisy. So the connection from the wiper to here becomes bad. You can try just putting switch cleaner in and cleaning them, but you may not find it's that successful as much as you would wish. Quite often, if you take them apart and you clean all these fingers, you can see yourself just rubbing against them, they went much cleaner. Yeah. And we can do the same with the track, use a bit of ISO or switch cleaner. And again, we can just give it a clean. Both, because remember we have to make a contact to both sides. So that may well fix your problem with crackling. But if there's been a lot of dust inside here, what happens is, as the slider moves up and down to the track, the dust effectively scratches this surface, and you may find that even with cleaning it, you can't get rid of the crackling, in which case really the only way to repair it is to just replace it. Okay, you can see these, it's easy for dust and liquid also to get inside these. Yeah, you can see something's got inside this one. This is very common, especially with DJ mixers where they have pints of beer sitting next to them. Not the best combination, but they all seem to do it. And when I was DJing, I did it also, so I can't really complain about that. Yeah. So that's how you would go around cleaning these and how you would repair any bad contacts at the end of the tracks. Reassembly is quite simple. Okay, but with the logarithmic one, try to put it in the right way round. Make a note which end was which before you do it, because if you get it the wrong way round, it might not work as you wish it to. Okay, so these will go back together, and you can see it's all reassembled. So those are quite easy. There is a gap through here. You can put switch cleaner in and slide them backwards and forwards to clean them, but if you are going to be successful, it's more likely that will happen if you take them apart. There is another variation on this which occurs both in these rotary ones and the sliders, and this is where you get a twin potentiometer, usually found in stereo audio circuits. So effectively this is two of them on the same shaft, two of the horseshoe shaped things. Okay, and as you adjust it adjusts both. These can be quite useful sometimes. For example, if you wanted a 50k potentiometer and you only have 100k ones, and the one you want is not stereo, it's just a single one, what you can do with these is you can actually connect the two sets of tracks in parallel with each other, just bend them over, solder the ends together, solder the sliders together, and then effectively you end up with two of them wired in parallel. And instead of having a stereo 100k, you'll have a mono 50k. Okay, so that's another way you can fix these things. In fact, if you look at this one, it's slightly different. In fact, this has 50k adjustment on the front side and 100k on the back side. So that effectively, if you put them in parallel, would give you, well, two 50s in parallel would give you 25. So a 50 and a 100 in parallel will give you halfway between 25 and 50, which is what, 37? Yeah, something like that. Okay, so you can also do that sort of thing, and you will sometimes find these. Interestingly, I just happened to pick one up. That's not particularly common. Normally with the stereo ones, both sides are the same value. This one's just 100k, yeah, on both. One other thing you can do with these, if you have, for example, this one, which is a 500k potentiometer, and it's broken, sometimes these just physically get broken. This is the track taken out of one that had completely fell apart, all the plastic parts had broken up. Sometimes you can actually take another one apart, and if it's the same design, this one is actually a little bit different. But if it's the same design, you can then take the track out of the broken one and put it back together inside a good one. Okay, so you can use the parts from one and reassemble it with the track from the other one, and then you will have a potentiometer of the value that you wish. I can't do it with these two because they are slightly different designs, but I'm sure you can see how that would work if we had a replacement one of the same design, the same type, but a different value. So by swapping these tracks over, you can get one of the value that you require, the broken one. Okay, I think that's it then. A nice short video, all you need to know about potentiometers to fix stuff. Very interested to hear any more hints and tips and suggestions in the comments below. And I look forward to seeing you all again soon. Ciao for now, guys.